to my fifth lecture. So in this lecture we will discuss on property of impulse function. In the previous lecture we have studied that area of unit impulse is equal to 1, and we have seen that for short duration delta approaches to 0, delta of delta t is equal to delta t, and we have also found a relation that is d by dt of u of t is equal to our impulse function. So if you haven't watched my previous video, the link is in the description below. So let's get started toward this lecture with our scaling property. Okay, so this is my scaling property, that is delta of alpha t is 1 upon mod of alpha delta t. So I will prove this equation. So let us take a case, that is delta of 2t. I want to find out what it is. So we know that our delta t is nothing but delta of delta t, where delta approaches to 0, and it's look like something like this. Okay, so here it is delta and here it is 1 by delta, as area of our unit impulse function is 1. Okay, so now if I will plot delta of 2t, so it is time scaling, so this signal will look something like this. Delta by 2, and since I am not changing the amplitude, so it will be 1 by delta. Okay, so I need to find the area of this delta of 2t. Area of delta of 2t, so it will be equal to 1 by delta into delta by 2. Okay, so it is equal to 1 by 2. So is it satisfying my this equation or not? We have to check it out. See, now if I found the area of this delta of alpha t, and here in this case alpha is greater than 0. Okay, so this equation will look something like this, that is minus infinity to infinity delta of alpha t. Since it is greater than 0, alpha is greater than 0, so I can take it this out, 1 by alpha and delta t into d of t. We know that area of an impulse is equal to 1, so it is equal to 1 by alpha. So here in this case also it is equal to 1 by alpha, that is equal to 1 by 2. So my this equation is satisfied. Okay, now if alpha is, this is for alpha greater than 0. If alpha is less than 0, if alpha is less than 0, then it will become delta of minus 2t. So my graph will look something like this. We'll draw with some other color. It will look something like this, minus delta by 2, and here it is 1 by delta, since I am not changing my amplitude, and this is time axis t. Now area of this, area of delta of minus 2t is equal to 1 by delta into the width is delta by 2. So in this case also it is 1 by 2. So thereby we have in this equation we have add a modulus on mod alpha. Okay, if you have any doubt you can ask to me. What I have done here is, first I have applied the time scaling property here, that is time scaling. Since I am not changing the amplitude, so the amplitude will remain same, then I need to find the area of this signal delta of 2t. So what I found out, it is equal to 1 by 2. Okay, so when I find out area of this, it is minus infinity delta of alpha t. So it is 1 by alpha of delta t into d of t is equal to 1 by alpha, and also in this case it is also equal to 1 by 2. So thereby we add a modulus there. Okay, now moving toward our product property, what it says that when a signal multiplied with an impulse will give me the value of a signal at a point where my impulse is present. Okay, that is x of 0 into del of t. Now see, this is my signal x of t. When I multiply this signal with an impulse at time t equal to 0, it will give me the value of my signal where my impulse is present, that is at x equal to 0. So here the area of my impulse is 1, and now area of my impulse is equal to a. Okay, that's why here in this equation I had replaced t with equal to 0. So this equation will reduce to x of t equal to del of t equal to x of 0 into del of t. Okay, now moving to our another case, if the impulse is time delay or time shifted. So this is my del of t, and if I time delay my signal with unit t naught, then it will shift in the right hand direction. So it will look something like this. When I multiply this signal with my impulse, so it will give me the value of my signal where impulse is present. Okay, so my impulse is present at time t equal to t naught. Okay, so it will give me the value of my impulse. Okay, so the value of my impulse at this point is x of t naught. So here in this equation I have replaced this t with t naught. Okay, so what we need to do, we need to replace our signal where impulse is present. Here in this case impulse is present at time t equal to t naught. So just replace the signal where our impulse is present. Okay, so I think it is very fine. Okay, now moving toward our shifting property also, it is very simple. Shifting property. So in this property it is minus infinity to infinity x of t into del of t into d of t is equal to x of 0. I can prove it also. So first we put down into a rectangle box. So now I will prove it also. So this is our proof here. So x of t into del of t dt. So I can write this equation as, with our product property, it is x of 0 into del of t into dt by using our product property, this property. Okay, so I will write it down here using product property. Okay, since x of 0 is independent of t, so I can take x of 0 out here, and we know that area of an impulse is equal to 1. So this minus infinity to infinity del of t dt is equal to 1. Okay, so this equation will reduce to x of 0. So this property is fine. Okay, now there are two more cases of our shifting property. So minus infinity to infinity x of t del of t minus t naught is equal to x of t naught. So in this case my impulse is present at, this is my 0, impulse is present at t naught, and in this case my impulse is present at, this is 0, my impulse is present at minus t naught. Okay, so let us prove it also. So I will write down here proof. Okay, so minus infinity to infinity x of t del of t minus t naught. So by using our product property, so replace my signal where the impulse is present. So it will look something like this. Here it is d of t del of t minus t naught into d of t is equal to, so here it is independent of t, so it will look something like this. So I can take this out, x of t naught and del of t minus t naught into d of t. Since my area of my impulse is equal to 1, so it will equal to x of T naught. So my first case is satisfied. Okay, now moving toward our second case, that is minus infinity to infinity x of t del of t plus t naught into d of t. So my impulse is present at minus t naught. Okay, so replacing the signal with where impulse is present, then using my product property here, product property, so it will become something like this: x of minus t naught and del of t plus t naught into d of t. Since it is independent of t, this part, so I can take this out. Since area of my impulse is equal to 1, so it is x of minus of t naught. Okay, so my second case is also satisfied. Okay, so here it is actually, there is also one more term here. Here it is d of t also, d of t. Okay, this is equal to sign. So in the next class we are going to solve problems on unit impulse and unit step functions, and we will look some tough problem also. So if you like my lecture, please give me a thumbs up and please subscribe to my channel. Please visit my blog also, because I used to give updates there, and please share and subscribe. Thank you, goodbye, and keep learning.